All right, so next we have the Transparent Firewall to talk about. Transparent Firewall being done as a layer 2 firewall or something called stealth firewall or bump in the wire. Basically what you have happening is the traffic bridged between the two interfaces. With the traffic bridged between the two interfaces, a single layer 3 subnet for both sides that's shared. So slight configuration changes we've made. Looking at the topology that we had, in this case, taking the configuration on ASA2, pulling ASA2's failover configuration off, moving it back over to the right side of the topology, so over and over here. So ASA2 being now over here on the right side of the topology. Another slight change we made, router 6, putting router 6's interface here in the same subnet as router 3. We're also going to go ahead and add on the routing protocol on router 6, add in some OSPF there. So on router 6, go ahead and just add an OSPF process for that network. Then when our transparent firewall is up and running, should have route information received for the rest of the topology. It's a slight change, changing the ASA2 in the upper corner there. Other slight changes made during the break, took the VLANs on ASA2, moved those back so the ASA2 has its outside Ethernet 00 interface in VLAN 39 and the inside Ethernet 01 interface in the other VLAN, VLAN 69. So we have those set up there. Next, we're going to quick discussion on some of the other miscellaneous items. So we said having that traffic same subnet. Because of that, we do need to have the same subnet on both sides. We need to have an IP address that's part of that subnet for it to properly pass that traffic and do the pass-through for the information itself. Traffic, in this case, building a CAM table. So building a table of information, MAC addresses, where they are, where they're located, who the devices are. So passing that information through. When the traffic does get passed through, it will still maintain the original MAC addresses. In this case, router 6 would ARP and get a response back with router 3's actual MAC address. It would be on the port connected to, or the ASA was connected to the switch. So in the event you did have something like port security on that port, you could potentially run into other issues there. General rules, your outside to inside sort of policy generally is still going to work with the higher security levels, lower security levels, having these securities set up on the interface. Again, you can get through that with having ACL exceptions in there as well. So basic setup, this is the firewall transparent mode. Firewall transparent being the command to initiate that. So for the most part, pretty straightforward as far as general setup. We've taken ASA2, we took off failover, went ahead and just switched it back to single context mode. Switch over to ASA2. To ASA2. Going to hit firewall transparent. And what do we notice there? We lost our host name. So our configuration did change because it's different for configuration perspective, the transparent versus regular mode. We do show mode, show firewall. Our mode, we did switch back to single context, and show firewall should show us as transparent now. It does. Show run here. Look at our existing configuration on a device. In this case, we have our interfaces. Our main interface is shut down. Generally shorter configuration. Everything else that we had was cleared out. We're going to go ahead, looking back at our topology, go ahead and enable our interfaces. For interface Ethernet 0, our outside. Again, still have names and security levels needed. Name if outside. Outside defaulting to 0 for the security level. Because it's transparent mode, we don't put an IP address here. If you try and put an IP address here, it will still take the command, but what it does is it takes it and shuffles it off to the global configuration mode. The ASA will allow you to have a command in a configuration submode that command doesn't belong in. In this case, as a global option, global config command, it will pull that off to the global configuration after you put the command in. Took the command in fine. It did pull it off to global, and notice it did also exit me out of interface configuration mode. I'm going to go ahead and do a show run, show what that appears in here. And my interface is still shut down. I didn't do a no shut there, so we need to get that as well. Then my IP address did get pulled off globally. We're going to go ahead and on the interface itself, Ethernet 0, do the no shut. Interface Ethernet 01. Give it a name. Again, default for the inside is going to be 100 for the security level. And make sure we no shut this interface as well. Again, don't need an IP address here. It just has the one configured globally. It is bridging between these two VLANs. So I have VLAN 39 and VLAN 69. In this case, that part is handled on the switch itself. So on the switch itself, having the VLAN information there. So the switch has one of the ASA interfaces in VLAN 39, the other interface in VLAN 69. As far as the ASA itself is concerned, it's just using the physical interfaces Ethernet 00 and 01 and bridging that traffic between those two. In this case, just a quick check, verify that you can ping both sides. Try and ping router 3, have success ping router 3. And router 6, as mentioned, we did give it a separate address in this subnet. So we changed its address. And we have success pinging to router 6 as well. We switch over to router 6 as our inside device. And try and ping from there. 9.9 as my address of the ASA in the middle. If I try and ping the 39.3, at this point I am not receiving a response. So I still have some of the same general types of rules, traffic not passing through. Now in this case, the ASA having connectivity to both sides, I should still be able to telnet and establish other connections through that device. In this case showing I can telnet to router 3 because that's a TCP connection, TCP UDP being inspected there and having information in the state table. If I establish that connection again, go ahead and look at my information on the ASA. In this case, show connection detail again, looking at the information, again, showing my individual flags, UIO, inbound, outbound information, and that the connection is up. So we've got a basic connection here. Switch back to router 6. Router 3, look at the information here. OSPF neighbors. In this case, router 3 shows router 2 as an OSPF, but does not show router 6 as an OSPF neighbor. We're going to go ahead and look at our interface as well. Show IP OSPF interface. In this case, we do show FA00 as an interface running OSPF. We'll look at the same thing on router 6. Off the telnet connection there. Show IP OSPF interface. In this particular case, showing that we have information here, showing we do have OSPF enabled on that particular interface. Debug IP OSPF adjacency. Debug IP OSPF packet. Take a look at what we see here. Set to debugging here. We'll give this just a minute and see what sort of messages we get. Look on router 3 as well. In this case, we're able to establish connection through the device, able to send TCP traffic. In this case, showing we're receiving traffic from router 2. In this case, based on the router ID 150.1.2.2. Not receiving other information on router 6. Router 6 not showing other information there. So we're going to go ahead and take a look at our firewall. See what our firewall tells us. Again, using the capture command. At the inside interface. Go ahead and throw in the real time as well. So we do see traffic hitting that interface. And go ahead and do the same thing on the outside interface. Going back up here again, looking at the various traffic we do see. In this case, recognizing this as OSPF traffic, the 224.0.0.5. This traffic up here, 224.0.0.9, is something else. This is 520 and this is UDP. This actually happens to be RIP traffic. The RIP traffic we're seeing there as well. So different type of traffic being seen. In this case, we're seeing the traffic come in. On the one side, we're seeing it come in from 3 to that address and 6 to that address. On the other side, seeing it from 6 to that address. So traffic not being allowed through the device. Go ahead and configure an access list. Call this access list O. Now we could be specific and just allow the from the host to the multicast address or to the neighbor address. We're going to go ahead and just do a permit OSPF any. And apply that to the interface. Again, capture can be good if you're seeing some traffic and not seeing other traffic. Try and debug what's happening, what's not happening. Back to router 3. We'll look at our logging information. So looking at our logging information, we see some DR, BDR information. We see some OSPF election happening here. Information going on. Looking at our OSPF information here, we do show that we now have a full adjacency to router 6. And our debug is showing we've got adjacency switched over to full. We're going to go ahead and turn off our debugging information. So again, at this point, the transparent firewall, quick review, having the same subnet on both sides, have a IP address configured on the transparent firewall itself that is in that same subnet, passing the traffic through on both sides. So he's passing the traffic through. Traffic gets passed to the other side. Same sort of rules apply as far as what traffic being allowed to pass, not allowed to pass, being inspected or not inspected. In this case, looking at traffic, we go ahead and turn on something like ICMP. In case my neighbor has switched from full to down and then came back up. We're going to come back to that in just a second here. Ping to router 6. And try and ping router 3. And if we're not allowing the ICMP through, turn off our debugs here as well. But looking at router 3 is sending that traffic back. He's getting the ICMP traffic through. He's trying to send it back. Again, because the firewall's not allowing it in the other direction, not passing that through the firewall. Now on the firewall itself, as mentioned earlier, as we did in the routed mode, we can also add in either an access list entry for the ICMP, or we could modify the existing policy there. We're going to go ahead and just do this easy way and allow it in their access list. And this is an inbound access list. We're just going to allow the echo reply, allowing that traffic back that was being initiated there. Back to router 6. Again, showing those pings are now passing through just fine. So slight differences on there. Again, most of the same rules apply. Traffic to watch out for, traffic to be aware of. Things like multicast traffic, traffic that's not TCP or UDP traffic, things are not being allowed to just float through by default. I'm going to just turn off the debug. Now in this case, we are seeing some issues on the adjacency. The adjacency itself looks like it's flapping. We're going to go ahead and adjust things on the ASA. Now we did have our traffic being allowed for the one direction. We're going to go ahead and allow it in the other direction as well. Is make sure it's not the traffic's being blocked. So we're just going to add in on the inside interface a access list to permit that traffic. Now, if we just have an access list on our inside interface that says permit OSPF any, the problem with that is that we would end up blocking other traffic that we did not have the permits for in the access list. So since we trust our inside interface, we are going to go ahead and allow that have free reign at this point, allowing any traffic coming in that interface. I have had some people say that they just had it permitted in one direction and it was fine. In general, I have seen cases of the OSPF neighbor relationship flapping like that if it's not permitted for the OSPF traffic in both directions. So think of things like that on the transparent firewall. May need to have items specifically permitted in both directions. Again, because that means putting an access list on an inside interface, in this case, opening that up with a any to allow that traffic, but also to allow other traffic that would be affected by the ASA as well. So different types of traffic to be aware of. Take a look at the information we see on router 3. Do a show ARP on router 3. Take a look at router 6 as well. Router 6 itself and router 3 looking at those addresses. So router 3 looking at his ARP information for the address of router 6. He sees that address, in this case ending with AEE0. That is the same address that router 6 has. Again, the MAC information staying the same as it passes through that transparent firewall. Similarly, the router 6 has information for router 3. That information for router 3 is the same as what router 3 has for his own local MAC information. Any other general questions on the transparent firewall information? Some of the other miscellaneous features we have with the transparent firewall, you have a couple of miscellaneous options that are specific to that. One of those is the ability to get into ARP inspection because it is looking at the layer 2 information. By default, he's forwarding that ARP traffic out the other subnet from where he heard it. So if he hears it on the inside interface, flooding it out the outside. If you want to, you can also override that and not flood that. You can also have static ARP entries with ARP inspection on. If you have static entries and it hasn't seen the other traffic through, or someone's trying to spoof it with a different address, you can go ahead and drop those entries. So additional item that can be configured in there. In addition to the access list, we looked at the ability of doing the layer 3 access list, in this case matching IP traffic or OSPF traffic. With the transparent firewall, you can also configure a layer 2 MAC access list. And you can actually have one of each on the interface. You can have both a MAC access list and a layer 3 IP access list. So in the event you wanted to permit other traffic to pass freely across your transparent firewall, you can do that. Different possible options that you have there. Now with that, be very careful with your MAC access list. It is possible that a misconfigured MAC access list could cause other things to break. By default, is not going to be too bad. But if you do have a MAC access list configured, then potentially could block other traffic. By default, at the end of an access list, you have a deny, and the deny statement is going to prevent other traffic from passing. So the implicit deny at the end of an access list. With a MAC access list on the firewall, it does by default, if you haven't explicitly denied it, at the end it will still permit IP traffic and it will still permit ARP traffic. So different types of traffic that is still going to be allowed by default in that particular MAC access list. Slightly different options there as far as configuring those different types of access lists in conjunction with an IP access list. In addition to the ARP spoofing and ARP inspection, you can also configure static MAC entries for where items are, as well as having the MAC learning enabled or disabled for particular interfaces. If you want to prevent unauthorized hosts, you can just get into static entries as far as where those hosts should be or shouldn't be. So a variety of different types of things you can configure. Again, be aware of different possibilities, be aware of your different configuration modes. Make sure you're very comfortable on the firewall itself, different modes you have, different options you have. Being able to look at a section and understand what they're asking you to do. For the most part, things like transparent firewalls, working with context, possibly working with failover, can be the types of things that can trip people up. For the scope of the lab exam, you want to make sure you've practiced a variety of different scenarios and feel very comfortable with those. Any other general questions on the transparent firewall?